You've got carboxylic acid, thionyl chloride. You know what could happen. That basically makes this carboxylic acid into acid chloride, right? Then you have an amine. Amine is a nucleophile. That makes an attack to the carbonyl of the acid chloride. That makes a tetrahedral intermediate, right? And it's coming back, and then you get the carbonyl back. Kick the chlorides out. That means that your nitrogen is going to be substituted with chlorine, so you get an amide form. So that is a problem. We talked about many times. It's not too difficult to understand how this goes. And this transformation, you get the carboxylic acid, right? That portions is these portions, and then OH replaced by the alpha chain. So must be the carbonucleophile that we need to use for that. If you think about using it as a Grignard, that is not going to work because if you just treat the Grignard, then acid will basically kill you. But if you transform the acid into an acid chloride, then we just talked about the reaction. Grignard, yeah, certainly if you attack once, then you get this, but this can react again, so you get the tertiary alcohol. That is the problem of using Grignard with an acid chloride. We've been discussing alcohol Chem 1. So I'm pretty sure you heard me saying it many, many times. Do not use an Grignard to make a ketone from an acid chloride. Instead, you need to use a weaker nucleophile, which is diallyl cuprate. You've got two isobutene groups on copper. That's the one that you need to use it. You place a chlorine once, so you get ketone. All right. This is if you see this in the question, it's probably one of the easy questions to you. Acid becomes an ester. There's so many different ways to make it, right? So, but it is not too difficult to get it. You need an alcohol, carboxylic acid, and then acid catalyst, and then you can make an ester. This is a very, very easy question. Why am I showing that is? Well, I want to show you other way to make it. Fischer acidification is one way to go. You can convert that as an acid chloride, and then you can use an alcohol to make this same thing. But the third way is you take its protons away, you make the carboxylate, and then you're using an ethyl bromide, and then make an SN2 reactions, and you can make that. So sometimes people forget that SN2 reaction can also be used to make an ester. I just trying to remind you. I know I've been repeating them every time today. I'm just trying to inscribe that into your brain. But I guess today you are all hearing me saying that a lot. But anyway, this is kind of what people forget that all reaction like SN2 still can be used to make something that can be made in other ways. This conversion is a carboxylic acid becomes an aldehyde. I'm pretty sure you remember the reaction we just talked about. We can either way completely reduce to the primary alcohol, right? Then oxidize it by the PCC, PDC, choline, swan oxidation. Those things are just oxidizing primary alcohol only to the aldehyde. So that's the one way to go. Another way to go is you can do the reduction. That if you hate this using lithium aluminum hydride, you could potentially use a borane now, right? The borane, we use the carboxylic acid to an alcohol, and then do these things. And or use an acid, you make an acid chloride from the carboxylic acid, then you need a really, really weak hydride. That is a lithium aluminum hydride with the 3 of the oxygen groups there. That will make only the hydride delivered once, and then everything stops the reaction there. So there's a variety of different things you can use now. So that's why it's really difficult to make the test not cumulative at this point. So final exam of Chem 2 is a really cumulative exam. Everything comes. Well, how you're going to do this transformation is basically what we kind of discussed that. You've got carboxylic acid becomes a primary alcohol. So many of you just going to jump there, oh, I'm going to use lithium hydride, but you shouldn't forget that we've got the ketone sitting right there, and then that is stay as a ketone in the end. So whatever we do, we have to stay the ketone. So if you think about it, if you have to use lithium hydride, then you should remember that it will be used both ends. This will be the primary alcohol, that will be secondary alcohol. So that is not that is not the good way to go. So another way is, if you're using a sodium borohydride, this is the only one that sodium borohydride can do reduction, because the sodium borohydride is not powerful enough. It's not going to do anything for the carboxylic acid. You get this, it comes just a secondary alcohol. So you got to know your need what they can do. So this is where you need to remember the borane. Right? The boranes are very selective to the carboxylic acid. It's not going to be used with ketones. So you get this using a borane. But if you forget that, one other way to do it is you can protect the ketone as an acetal, cyclic acetal. And then you can use whatever the lithium hydride, you use that to primary alcohol, release the acetal by the acidic water, then you get the product. So that I already show you. I just want to remind you what will happen with other reagents.